Hey guys, today we're covering topic 7, which is hydrocarbons, including alkanes and alkenes, alcohols, carboxylic acids, crude oil, fractional distillation, and condensation and addition polymerization.
A hydrocarbon is only made from hydrogen and oxygen. A homologous series is a group of compounds that react in similar ways, the most basic of these being alkanes. Hydrocarbons with a general formula of CnH2n plus 2. They are saturated compounds, the first being methane, ethane, propane, and butane, shown here. As the length of a hydrocarbon chain decreases, it gets more viscous, has a lower boiling point, and is more flammable. As the chain length increases, vice versa. This means short-chain hydrocarbons are used more as fuels, as we'll see later. Complete combustion of any hydrocarbon in oxygen produces carbon dioxide and water in a process where the carbon and hydrogen are both oxidized, lost electrons to bond with oxygen. An important exam skill to have is balancing equations, so maybe brush up on this when you revise this topic. Crude oil is a finite and non-renewable fuel. It is very unsustainable because it takes several million years to produce. Fractional distillation separates crude oil into its constituent alkanes. It is very likely you will be asked how fractional distillation works in your exam, so listen carefully. The crude oil enters the fractionating column at high temperature and pressure. At the bottom of the column, it is really hot, and the temperature decreases as you go higher. The very longest hydrocarbons, think C40+, immediately condense into a liquid at the bottom and are pumped off. All the other shorter chains rise up the levels, pushing through the bubble caps until their boiling point, where they will condense into their fraction and be pumped off. This is useful because hydrocarbons are now separated into similar boiling points and thus similar chain lengths. Crude oil is useful for transport fuels, such as diesel, and as building blocks to make polymers. They also help make all kinds of different organic compounds that will be seen later in this topic. Short-chain hydrocarbons are more useful and in demand but low supply. So a process called cracking turns long-chain hydrocarbons into shorter-chain ones. This also produces another homologous group, called alkenes, which are also useful in fuels and polymers. This can be done through catalytic cracking, whereby hydrocarbons are heated to a vapour and passed over a hot aluminium oxide catalyst to break them into smaller molecules. This can also be done by steam cracking, where they are mixed with steam and then heated to a very high temperature. This will usually produce several alkenes and one alkane. Alkenes have a double bond between two of the carbon atoms in their chain, and so have two fewer hydrogens attached here, and so are called unsaturated hydrocarbons. They have the general formula CnH2n, and the first four are ethene, propene, butene, and pentene. Alkenes combust completely to produce water and CO2, but only in pure oxygen. In air, they tend to combust incompletely, producing carbon monoxide and carbon particles. This is shown in the smoky yellow flame they produce, and the less energy that is produced. The alkenes, CC bond, can open up and react with other compounds too, called addition reactions. Addition of hydrogen to an alkene is called hydrogenation, to make a saturated alkene in the presence of a catalyst. They also react with halogens, such as chlorine, bromine, and iodine, in an addition reaction as shown. And more on how these reactions will work is at A level. Bright orange bromine water can be added to test for the presence of alkenes, where a positive result will turn the solution colourless. Steam can also be reacted with alkenes to form alcohols, e.g. ethene reacting with steam to make ethanol is a very useful reaction. Plastics are made out of long-chain molecules called polymers, which are made from basic subunits called monomers, in a reaction process called polymerization. The monomers used to make plastic are usually unsaturated alkenes, which open up their double bond to make a polymer chain, in a process called addition polymerization. This is usually shown as brackets with an N to symbolize any number of repeating units due to the chain's large length. When monomers react in addition polymerization, there are no byproducts. This is useful when drawing the display formula for addition polymerization reactions. Always remember to draw the lines extending outside the brackets and write the N to gain all extra possible marks in your exam. Alcohols are a homologous series with the functional group OH, and their general formula is CnH2n+1OH. The first four alcohols are methanol, ethanol, propanol, and butanol. The basic naming system is the same for alkenes and alkanes, but the end suffix is -ol instead of -ene or -ane. Alcohols are flammable, producing CO2 and water in complete combustion. Up to butanol, they are all soluble in water, and their solutions all have a neutral pH. They can also react with sodium to make hydrogen. They can be oxidized to produce a carboxylic acid, as discussed a little later. Alcohols are also useful as solvents, because they can dissolve oils and fats, as well as everything the water can. The most useful ones being methanol and ethanol. They can also be burnt as fuels because they are clean and not smelly. Furthermore, ethanol can also be made through fermentation to make alcoholic drinks. The process uses yeast to convert sugar into ethanol and carbon dioxide. This happens most efficiently at 37 degrees C, in a slightly acidic pH and no oxygen. Carboxylic acids have a COOH functional group, and the first four are methanoic acid, ethanoic acid, propanoic acid, and butanoic acid. It is important to learn the names and structures for all of the compounds mentioned on this topic, as they can all be assessed upon in your exams. Carboxylic acids also react with carbonates to make a salt, ending in anoate, water, and CO2. They can also dissolve in water, where they ionize completely to make H+ weakly acidic solutions. They can also make esters, which have the functional group COO. The most common example is ethyl ethanoate, which is made from ethanoic acid and ethanol. In naming, remember the carboxylic acid goes to the anoate bit, and the alcohol goes to the yle bit, and water is also produced. Please practice naming esters, because it is a bit complicated, and something a lot of students struggle with. I will link some of the help down below. Polymers can also be made through condensation polymerization, try saying that 3 times, where unlike addition polymers, they contain 2 or more different functional groups, which all bond together in a repeat to make the polymer. Water is usually a byproduct of the process, e.g. how polymers can be made by condensation polymerization. At GCSE level, the only monomers you'll see in condensation polymerization are either 2 monomers each with 2 of the same functional groups, or 1 monomer with 2 different functional groups. This is different to addition polymerization, where you'll only find alkenes reacting. Finally, polymers can also be found in the natural world. Amino acids contain an amino group and an acidic carboxyl group, as shown in glycine. Proteins are polymers of amino acids called polypeptide, formed from condensation reactions, where water is also lost, e.g. in glycine here. Proteins are very useful in the body as catalysts. Hemoglobin to transport oxygen, antibodies, and as tissues. Different amino acids can be combined in different ways to make different proteins with different shapes to have different uses. DNA molecules are also made from nucleotide polymers, where the order of the bases codes for the genes of the organism. And sugars can bond together to make starch, which is used in plant cell walls.
Hey guys, thank you so much for watching. The link to the MINDMAP will be in the description box below, completely free to download. Don't like, subscribe and follow. That's not what I want you to do. Okay, if you have any questions, I'm happy to answer them down in the comments. I will see you in the next one.